Okay, welcome back. In this video, we will do some examples using Laplace's expansion. So number page 3 is examples. Okay. So the first one says, first example says using Laplace formula, find the determinant of t, which is 1, 3, 3, 2. So earlier in this chapter, we have used Gauss's method to find the determinant of this matrix, and we found that the determinant of t was equal to -7 using Gauss's method. Okay. Now we are going to use Laplace's expansion formula to be able to find the determinant of this matrix. So a quick recall of the Laplace's expansion formula says determinant of t is equal to sum of j going from 1 to n of tij multiplied by the cofactor ij. So, and the cofactor, okay, t ij, it is equal to -1 I plus j multiplied by determinant of the minor. The minor is the matrix we get after deleting I row and j column. Okay, so let's use this formula to find the determinant of this 2 by 2 matrix. So let's change the color. So using this formula, so let's solution. Okay, so first of all, let's find the minor of the matrix T, and we are going to do the expansion along row 1. Okay, so we are going to expand row 1. So determinant of T is going to be equal to, we have a 2 column, so it's going to be T 1 1 multiplied by the cofactor 1 1 plus T 1 2 multiplied by the cofactor 1 2, because we have 2 columns here, so j is going from 1 to 2. Okay, column 1, column 2, 1 2. Now let's find okay, so let's go. We have a t11, which is the entry. Okay, the ti's, the small t's are the entries. So along row 1, t11 is equal to 1 multiplied by the cofactor 1 1. If you remember the, okay, let me do some work here. T11 is going to be -1. Okay, let me do it here, maybe it's better. Okay, so let me keep T11, and we said that the cofactor is T11 is -1 to the power of 1 plus 1, I plus j. So here we have the cofactor formula here. I plus j multiplied by the determinant of the ij minor. Okay, so ij minor, determinant of so how do we get to the ij minor? Let me give you an example here. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have the following matrix, and we say that the ij minor, okay, is the minus n. So it's n minus 1 by n minus 1 matrix we get by deleting row I and column j. So if we take this matrix, let's call it A. So the ij, the uh, one, sorry, the one minor that I called T tilde 1, 1 is going to be the matrix we get if we delete row 1. Okay, if we delete row 1 and column 1, so we are left with the following matrix. So this is 5, 6, 8, 9. Okay, so that's the one minor. Let's see. Now let's go and find the 1, 2 minor. Okay, the 1, 2 minor is going to be the matrix we get if we delete the row 1 and column 2. So we are left with the following matrix: 4, 7, 6, 9. Okay, so that's 1, 2 minor. Okay, let's find the third minor of this matrix. So the T1, 3, the matrix we get by deleting row 1 and the column 3. So we are left with the 4, 7, 5, 8. So that's how you find the minors of a matrix. So let's do the same thing here. Let's continue our expansion along row 1. So here we have this is our cofactor, okay, T1, 1 now plus T1, 2 multiplied by the cofactor 1, 2, so we have minus 1, 1 plus 2, and multiplied by the determinant of the minor 1, 2. Okay, so here we have the entry 1, 1. Okay, first row, first column is 1, multiplied by minus 1 to the power of 2, multiplied by determinant of the matrix we will get after deleting first row and first column. We'll be left with just 2. And determinant of a scalar is that scalar. Okay, plus first row, second column, T1, 2. Okay, the entry T1, 2 is 3, multiplied by minus 1 to the power of 3, multiplied by determinant of deleting first row and second column. We are left with 3. Okay. So here 1 multiplied by minus 1 to the power of 2, which is equal to 1. So we are left with 2. Determinant of 2 is 2, plus 3 times minus 1, which is minus 3, multiplied by 3, which is minus 9, minus 9. So determinant is equal to minus 7. Okay, so we got the same answer as using Gauss's method. Okay, so you can find the determinant of a matrix either by using Gauss's method or by using Laplace's expansion formula. Let's now do the expansion for a 3 by 3 matrix. So question 2. We have using Laplace find the determinant of the following matrix. T is equal to 1, 1, 1, minus 1, 1, minus 1, 1, 3, 2. So we have seen earlier using Gauss's method that determinant of this matrix is equal to 2 using Gauss's method. Okay, now let's use Laplace's expansion formula to get the matrix, the determinant of this matrix. Okay, so the formula is going to be okay, a quick recall about Gauss's Laplace's formula. We have determinant of t is equal to, okay, j going from 1 to n of minus 1 to the power of I plus j Tij multiplied by determinant of the minor Tij. Okay, and here I like to put Tij first. So I'm going to say, and j here is going from 1 to 3. So it's going from 1 to 3. You have 3 columns here. And we are going to do the expansion along row 1. Okay, so we are going to expand along row 1, about row 1. Okay, so we have T1, 1 multiplied by minus 1 to the power of 1 plus 1 multiplied by determinant. Okay, T determinant of T tilde 1, 1 plus T1, 2 multiplied by minus 1, 1 plus 2 multiplied by determinant of the minor 1, 2, okay, plus T1, 3 multiplied by minus 1 to the power of 1 plus 3 multiplied by determinant of the minor 1, 3. Okay, so here we have the entry T11. Okay, so we are doing the expression about row 1. So T11 is equal to 1 multiplied by minus 1 to the power of 2 determinant of minor T11. So T11 is the matrix we get if you delete row 1 and column 1. So we are left with 1, 3 minus 1, 2 plus T12. Okay, so this is the second entry, the entry T12, the entry 1, 2. So we have 1 multiplied by minus 1 to the power of 3 multiplied by the determinant of the matrix. If we delete row 1 and the column 2, we are left with the minus 1, 1 minus 1, 2. Okay, plus the entry 1, 3, first row, third column, which is that multiplied by minus 1 to the power of 1 plus 3, which is equal to 4, multiplied by determinant for minor by deleting uh, first row and third column. So we are left with the minus 1, 1, 1, 3. Okay, so this is equal to 1 determinant of a 2 by 2 matrix. We know how to find the determinant. We know the formula. So here is 1. Okay, 1 multiplied by minus 1 to be squared, which is 1. 1 multiplied by the determinant here is 1 multiplied by 2 minus. Okay, so I can just get rid of this one. Minus 3 multiplied by minus 1. Okay. And here minus 1 to be cubed is going to be minus 1 multiplied by minus 1 multiplied by 2 minus 1 multiplied by minus 1. So here determinant of a 2 by 2 matrix is minus 1 multiplied by 2 minus 1 multiplied by minus 1 plus 1 multiplied by minus 1 multiplied by 3. Okay, I can get rid of this one. Okay, so minus 3 multiplied minus 1 multiplied by 3 minus 1 multiplied by 1. So we are left with the 2 plus 3 minus here. Inside here we have minus 2 plus 1 plus here we have minus 3 minus 3 minus 1. So here we are left with the 5 inside the bracket here minus 1, so it's plus 1, and here we have minus 3 minus 1, which is minus 4. So we have a 6 minus 4, which is equal to 2. So determinant of t is equal to 2. It's the same as you have the same answer as using Gauss's method. So this is going to be the end of this video. So in these two examples, we have seen how to find the determinant of a matrix using Laplace's expansion formula, also known as a cofactors expansion formula. Okay, thank you. And in the next video, we will start the fifth part of this section, okay, which is the definition of determinants as a size function. Okay, thank you.